Welcome to our tutorial on using GPT-5. Let's start with an overview of what we'll cover in this tutorial. GPT-5 is introduced as the most intelligent model yet, setting the stage for its new features and capabilities. Let's focus on three main strengths of GPT-5: code generation and refactoring, instruction following, and handling long contexts and tool integration. GPT-5 also excels at understanding and executing instructions provided by users. Finally, the model is well suited for tasks that involve long contexts and calling tools or APIs. New API features introduced with GPT-5 allow for greater control over verbosity, reasoning, and tool usage. Next, we'll take a look at the various models available in GPT-5. There are three models in the GPT-5 family, each offering a different balance between capability, cost, and speed. The main GPT-5 model is best for complex tasks that need broad world knowledge, while the smaller mini and nano models are faster and more affordable for well-defined jobs. Now let's discuss some key trade-offs to consider when selecting the right GPT-5 model for your needs. This table summarizes the recommended use cases for each GPT-5 model variant. The GPT-5 mini variant is optimized for speed and cost, offering a balanced choice for most general use cases. For high-throughput, simple tasks, GPT-5 Nano provides the most efficient performance and lowest latency. Let's look at the new API features that come with GPT-5. Along with GPT-5, new parameters and API features give developers more control and flexibility. Let's explore the minimal reasoning effort feature in GPT-5. The reasoning effort parameter lets you control how extensively the model reasons before responding. Previous models like O3 only supported low, medium, and high settings, where low was faster but less thorough, and high provided deeper reasoning at a cost. A new minimal setting allows the model to use as few reasoning tokens as possible for ultra-fast responses. The default setting remains at medium, but for speed-critical applications, minimal can reduce response times. The minimal setting is particularly effective for code generation and following instructions, but may need extra prompting to take initiative. To enhance reasoning quality when using minimal effort, prompt the model to think or outline its steps before giving a response. Here we show an example API request using curl to specify minimal reasoning effort. The key part of this request is the reasoning object, where effort is set to minimal to get the fastest possible response. Now let's look at how to make this API call using JavaScript and the OpenAI SDK. We begin by importing the OpenAI library and initializing the client object. Next, we use the responses.create method to send a prompt to the GPT-5 model. Notice the reasoning.effort parameter is set to minimal, requesting the model for the fastest response with minimal reasoning steps. Finally, the API call is complete and we can handle the response as needed. To demonstrate minimal reasoning effort, let's look at the Python example using the OpenAI client. Here, we prepare and send a response creation request using the GPT-5 model with the specific reasoning parameter set to minimal. The reasoning effort parameter is specified in the dictionary, telling the model to use minimal reasoning for a faster response. The response from the API call is stored in the variable response. Now let's print the result to see the model's minimal effort answer. Next, let's explore the verbosity parameter introduced through GPT-5. Verbosity in GPT-5 controls the length of outputs, finding a balance between response speed and completeness, which influences answer quality depending on your needs. High verbosity is ideal when you need the model to deliver comprehensive explanations or perform thorough code refactoring. Low verbosity is best for getting concise answers or generating simple code like short SQL queries. This curl command demonstrates how to call the GPT-5 API while specifying a low verbosity setting, which results in more concise answers. We start by importing the OpenAI library and initializing it for use in our application. Next, we create a response using the GPT-5 model, providing the question input and setting verbosity to low under the text property. Finally, the result from the model is printed to the console for review. Here we create a client using the OpenAI library and set up a response request with specific parameters. Notice in the request object that we provide the model name, the input query, and a text configuration with low verbosity. Here we print the API response to see the concise output generated by the model. You can further influence how verbose the model is by adjusting your prompts in addition to the API parameter. The verbosity setting acts as a guideline for response length, but both developer and user prompts can still shape the final output. GPT-5 introduces a capability called custom tools, allowing models to send any raw text as tool call input while optionally constraining outputs. Here we define a custom tool that allows the model to execute arbitrary Python code by sending raw text as input. The name and description fields specify the tool's identifier and its purpose for the model to use. GPT-5 also allows you to use context-free grammars to constrain tool outputs, ensuring responses match specific syntaxes or DSLs, such as SQL. The first best practice is to write concise and explicit tool descriptions, making it clear if the tool should always be called. The second best practice is to always validate outputs on the server side to prevent unsafe or unintended commands when using custom tools. The allowed tools parameter lets you define a larger set of tools but restrict usage to a specific subset, giving you fine-grained control over which tools the GPT-5 model can access at any moment. You list your complete toolkit in the tools parameter and then specify a subset in allowed tools, along with a mode that determines whether the model must pick one or can choose freely among them. Separating the set of available tools from those allowed at any given time increases safety and predictability in tool usage. This approach helps avoid brittle prompt engineering and hard-coded tool call orders, allowing GPT-5 to dynamically invoke the correct tools as needed. By limiting tool usage within long conversations, you also reduce the risk of unintended tool invocation and make prompt caching more reliable. Let's clarify the difference between standard tools and allowed tools using this comparison table. Under standard tools, the model considers all declared tools as potential options. With allowed tools, you can restrict or require the model to invoke only selected tools from your toolkit. Let's look at how the allowed tools parameter is set up in a sample API payload. Here, we specify the allowed tools by listing them inside the tools array, mixing function, MCP, and image generation types. Let's discuss the concept of preambles in GPT-5. Preambles are short, user-visible explanations generated by GPT-5 before any tool or function is called. They describe the model's intent or plan, making it clear why a specific tool is being used. Preambles typically appear after the model's reasoning and just before a tool call. This transparency helps users understand the model's thought process and improves debugging and steerability. By prompting GPT-5 to briefly explain its intent before calling a tool, you can increase both transparency and task success without adding unnecessary reasoning overhead. To enable preambles, simply add an instruction like, before you call a tool, explain why you are calling it, and GPT-5 will automatically prepend a concise rationale before each tool call. The model may also generate multiple explanatory messages between tool calls, enhancing user understanding, especially in minimal reasoning or latency-sensitive scenarios. When migrating to GPT-5 from older models, begin by testing different reasoning levels and prompt strategies to find what works best. We recommend using OpenAI's Prompt Optimizer, which updates your prompts for GPT-5 using best practices. Additionally, be sure to follow model-specific guidance to maximize your migration success. When migrating from other models, there are specific recommendations for equivalent GPT-5 settings. For users of O3, start with GPT-5 using medium reasoning and adjust to high if necessary. For those using GPT 4.1, switching to GPT-5 with minimal or low reasoning is recommended. If you previously used O4 Mini or GPT 4.1 Mini, GPT-5 Mini with prompt tuning is suggested. For those on GPT 4.1 Nano, GPT-5 Nano with prompt tuning is the best match. The Responses API allows for passing chain of thought between turns, which leads to smarter outputs, fewer reasoning tokens, higher cache hits, and lower latency. Most other parameters remain similar to previous APIs, though there are some formatting differences with the new parameters. Let's walk through a curl example to generate a response using GPT-5 with minimal reasoning effort. This first line uses the curl command to send an HTTP post request, which is how we interact with the OpenAI API from the terminal. Here, we provide the API endpoint URL so the request knows where to go. The next two lines set the necessary headers, including your API key for authorization and content type for JSON. The main request payload is supplied with the -- data flag as a JSON object containing our query. Within the JSON data, we specify the model as GPT-5 for our completion. The input field holds our actual question to the model, asking how much gold would be needed to coat the Statue of Liberty in a 1 mm layer. Next, we pass the reasoning parameter and set the effort to minimal, instructing the model to generate a response with very little internal reasoning. Here's how you would generate a response with minimal reasoning effort using the older Chat Completions API, for comparison with the Responses API. The core endpoint for Chat Completions is https://api.openai.com/completions, shown here. Your question for the model is included as a user message in the messages array. In Chat Completions, minimal reasoning is set by specifying the reasoning_effort parameter. This example demonstrates how to use the Responses API to generate a concise answer by setting verbosity to low. Setting verbosity to low is useful when you want short, to-the-point answers or minimal code without extra explanations. Here's how you control verbosity using the Chat Completions endpoint, which mirrors the previous Responses API example. The request still specifies the model, user message, and verbosity level, but uses the messages array and places verbosity at the top level. Here's how to use the Responses API to call a custom tool for code execution. Notice that within the tools list, we define a single custom tool named CodeExec and describe its function. Now, let's discuss how GPT-5 utilizes reasoning to solve problems effectively. GPT-5 approaches problems step by step, generating a chain of thought that records its reasoning process. To get the best results, you should pass these reasoning items back to the model during a conversation. This approach avoids re-reasoning and keeps your interactions aligned with how GPT-5 was trained. In multi-turn conversations, using the previous response ID automatically gives GPT-5 access to earlier reasoning steps. This is especially important for tool use cases where reasoning across multiple rounds is required. You can either pass reasoning directly using previous response ID or manually include those steps in your input to maintain continuity. Let's address some frequently asked questions about GPT-5 integration and migrations. In ChatGPT, there are two models, GPT-5 Chat and GPT-5 Thinking, that handle reasoning or minimal reasoning, with a routing layer choosing the best model for the user's query, or users can pick reasoning manually. GPT-5 will also be supported in Codex and Codex CLI, making it more widely available for development tasks. Any deprecation of previous models will be announced on the official deprecations page with advance notice to users.